Today I'd like to talk to you about Swift and philosophy. Now, it may seem like an unusual combination, but basically when I came up with the idea for this topic, I was reading this book called Zen and the Art of Motorcycle Maintenance by Robert Percy. Now, what it says on the cover is that, you can't really see it, but that the book will change the way you think and feel about your life. And that's a really big promise for a book. And what it does is it tells the story of a father and son who go on a motorcycle ride with two friends. And he looks at the motorcycle both as this machine, as a collection of pistons and grease and metal, but also as a vehicle for exploration and adventure. And by looking at their duality, it kind of opens up a conversation about philosophy, about life, the universe. And basically, as I was reading this book, I was wondering, could you kind of do the same thing with Swift? So we all know what Swift is, but what is philosophy? So philosophy comes from an ancient Greek word. It comes from philo and sophi, the love of wisdom. Now, that doesn't really mean that much, but as an sort of academic subject, it contains things like the meaning of life, morality, knowledge, reality, existence, consciousness, politics, linguistics. Pretty much every subject that humans have been interested in has its own sort of branch of philosophy. Now, that can be a bit overwhelming, so I like to think of philosophy as more of an exercise in thought, as a way of thinking hard about bigger issues. Now, philosophy can be a bit scary sometimes, and the reason why is sometimes you might hit some jargon. There's a lot of jargon in philosophy, like big complicated words that you have to somehow understand. And also we have the philosophers themselves, so, yes? No. The philosophers themselves, and there are these big characters of histories, and each one embodies a big idea, and they kind of reference each other, so you need to know a lot just to get started. But the good thing about philosophy is that it's built on top of logic, and logic is kind of what we're trained in as developers. It's what we deal with every day. So everyone here should have the capacity to understand and maybe love philosophy. Now, Swift is an Apple product, and Apple is a company that likes to see itself in this intersection between technology and liberal arts. And Steve Jobs was so adamant about this that he put the slide up twice in his last two keynotes, and as a way of summarizing what Apple products should be. And yeah, so Swift is an Apple product, and I wanted to find, basically, if we do this sort of basic Venn diagram, I wanted to find that kind of area in the middle, the area where Swift and philosophy overlap. And I wasn't even sure if this area existed, but yeah, I found these sort of three topics in philosophy that have some kind of relevance to our work as Swift developers. So we're going to talk about metaphysics, and that will be a very large part of the talk. And then we're going to talk about human progress, the philosophy of history, and we're going to talk a little bit about uncertainty as well. The way this is going to work is that we will talk about philosophy and explain it using Swift, but we're also going to talk about topics in Swift and explain them through philosophy. And if it gets too much, you know, there's a cat gif in the end, so there's something to look forward to. So let's start with metaphysics. What is metaphysics? Metaphysics is a topic basically trying to understand what is the world. And what is the world like? And this is something humanity has always been interested in. And it forms also the foundation of religion. And the first philosophers that we're going to talk about are the pre-Socratic philosophers. So Socrates was one of the big figures of ancient philosophy, and everyone who came before him we call pre-Socratic. And many of the pre-Socratic philosophers were concerned with finding the primary object of the universe, the thing that everything kind of is built out of. So in Swift terms, they kind of wanted to understand what any object is. And the first philosopher, the first documented Western philosopher that we know of is Thales. And Thales looked at the world around him. He looked at the sea, he looked at the rivers, the clouds, the blood in our veins, the food that we eat. And he concluded that everything is derived of water. And if you think about it, there is some sense to it, that humans are 70% water, the Earth is 70% water. And as soon as he came up with this everything is water dogma, other philosophers arrived, and we had Anaximenes, who said that the world is made of air. We had Heraclitus, who said that the world is made of fire. And this is basically how the conversation went on, until Plato arrived. So Plato published a book called The Republic. And The Republic is a collection of conversations between, so it features many characters. It features Socrates, who was Plato's teacher. It features Plato himself, and Aristotle, who was Plato's student. And if it may sound weird to you that all these sort of great ancient philosophers kind of knew each other and worked together, you need to understand that ancient Greece was kind of a small place. And Aristotle's student, who doesn't feature in The Republic, was Alexander the Great. So basically, The Republic talks about this concept of the theory of forms, and this is what's kind of relevant for us. The theory of forms says that the world as we perceive it is not necessarily the real world. And this may sound familiar to you if you've seen a certain popular film franchise. So in The Matrix, the great philosopher Morpheus asks Neo, what is reality for you? Is reality just what you experience through the senses, what you can touch and hear and smell and feel? And if it's that, then basically you're defining reality as the electrical signals interpreted by your brain. And these can be the cause of the consequence of reality, but they're not necessarily reality itself. And what Socrates said is that these forms are kind of the abstract representations of the idea of the thing, the essence of the thing that we're talking about. So, in Swift terms, I'd like to think of this as kind of as a superclass. A form is a superclass that everything else inherits from. So if you're talking, many examples in philosophy talk about a chair. And so if we have a class of a chair that implements all the functions and variables and everything that defines what a chair is, then every chair that exists afterwards, well, no matter how weird the chair is, it still inherits from the chair its essential chairiness. And even if it extends the functionality of the chair, like a swivel chair, it's still very much a chair because it inherits that basic chair qualities. Now, the great story, the popular story here is the story of the cave. It's a metaphor. And it's about a group of prisoners who've been kept in this cave and they've been chained so that they can only look at the wall. And behind the cave there's a road, and behind the road there's a fire. And as horses and carts and people, as they pass this road, the fire throws their shadow on the wall that the prisoners can look at. And basically in this story, the prisoners who were there their entire lives, their entire reality is these shadows. And if you ask them to describe what a horse is, they'll describe what we know to be the shadow of a horse. And what Plato said is that the philosopher, we are all caged in this kind of perception. And the philosopher is the person who was in this prison and was let out, and he saw the real world, and then he has to come back and explain it to the people who are chained in this prison. And that's a really powerful idea. So I mentioned Aristotle, who was Plato's student, and Aristotle was a bit of a rebel. He didn't accept all of Plato's ideas, and he was a big fan of deduction. He really pushed for deduction. So on the basic level, it's just saying that if A equals X and B equals X, A equals B. So if you're going back to our chair metaphor, the idea is if a chair is something that I can sit on, and I can sit on a rock, then this rock is a chair. And this is exemplified by this popular meme, if I fits, I sits. And in Swift terms, this is basically, instead of defining a chair as a superclass, we can look at chair as a kind of protocol. And then something becomes a chair by implementing the function of sitting. And yes, this is kind of like just a general sort of introduction to thoughts about the nature of objects. And now we're going to talk about the question of identity. So the big figure here is Plutarch, and Plutarch had a story about the ship of Theseus. And Theseus was an Athenian, and he had a ship, and he went on this voyage. And throughout this voyage, every day they would take a rotten piece of wood on the boat and replace it with a fresh piece of wood. And by the time he came back to Athens, the entire ship was replaced. And the question is, did Theseus' ship return? Is this still the ship? Another way of looking at it is by saying that you can't step in the same river twice. Every time you step in a river, the water is different, the rocks are different, the sand is different. And in Swift, like, this made me think about value and reference type. So in Objective-C, we were passing the same object around and we knew what was equal. But in Swift, we have structs and enums and tuples who represent a unique copy of their data. And then, if we try to represent the question of the paradox of Theseus' ship in Swift, we'll say we have a ship struct and we want to understand, compare the ships and see if they are equal. We have to implement the equatable protocol. So in a way, what the question asks is why? Like, basically, how does the universe implement equatable? And Aristotle had an answer to this. He presented the causes. So he said that basically every movement has four elements, four causes that cause it. So there's the material cause, which is basically what something is made of. There's the form, which is why it was designed to be the way that it is. There's efficient, which is how a thing works. And there's the end, which is the purpose of the thing. And Plato argued that the universe implements equatable by looking just at the form, by looking at if the design of the thing, the reason the thing was built the way it was built doesn't change, then the thing itself doesn't change. Now, all of this reality we perceive through the mind. And we're going to fast forward a bit, and we're going to talk about Immanuel Kant. And Immanuel Kant was, again, he was a big fan of jargon, so this is a warning. His big theory is called transcendental idealism. And transcendental idealism concerns itself with two ideas. The phenomena, which is reality as interpreted by our minds, and noumena, which is the reality that exists regardless of our interpretation. And I guess it can be kind of summarized by the idea that we will never know the things that we can't experience. And this made me think of scope and private functions. So if we go back to our chair example, the chair implements the function sitting by calling a private function that does secret chair things. Now our swivel chair subclass, we can't see into this function because it's outside of our scope. And in that way, the universe kind of behaves like a compiler. And hopefully not too much. And yeah, so no conversation about the mind would be complete without talking about René Descartes. And he's very famous for saying cogito ergo sum, which is translated to I think, therefore I am. And basically, the argument was that for a thought to exist, it might be created by something that exists itself. So if we have a class thought, it must be initialized by an existing object. And therefore, if I can create a thought, it means that I myself exist. He also presented the idea of Cartesian dualism, basically looking at the body as something that exists entirely in the physical plane, and the mind as something that exists in a different, non-physical plane. And the human is kind of what sits in between. So the human is basically the bridging header between the non-physical plane and the physical plane. And this also kind of makes sense, because humans are messy, and my bridging headers are messy. And yeah, and this kind of sums up the metaphysics part of the talk, so congratulations. The next bit we want to talk about is the philosophy of human progress. So this is relevant for us because Swift is kind of the future of Objective-C. And the main figure here, the historical figure, is Hegel. And Hegel's argument was that everything in the world is connected, that the present could not exist without the past and the future. And he coined the term zeitgeist, which in literal terms mean time ghost. But he used it to describe basically the multitude of factors that affect society at a given moment. And for us, it can be the culture, the history, the politics, everything kind of comes together in this thing that affects the spirit of the times. And he argued that progress happened in a dialectic fashion, which is a way of saying that it happens through argument. Basically, he agreed that there was this perfect form of a thing, but we existed with an imperfect form, and the reality that we perceived, it's not the false reality because of the senses, but it's a false reality because of what society agrees on, because of this zeitgeist. And the way progress happens is that whatever we all agree is great, flaws in it are revealed, and we find a system that has fewer flaws. And he argued that this transition happens by really sharp cuts. So it can be summarized as there's a thesis, which is the current situation, and it produces an antithesis, and then that produces synthesis. So we kind of experienced this. So in 2014, when I developed iPhone apps, I thought Objective-C was the best language ever. I had such a great time writing it. Everything looked so good. Whereas now in 2016, I code mostly in Swift, and every time I have to go back to Objective-C, I have to deal with these ats and semicolons and brackets, curly brackets. The whole thing seems like a mess, and I don't have all the new things Swift brought me. And we all know that in 2015, we won't even remember what Swift was, and we'll have this better, newer programming language that fixes all the things that made our Swift lives hell. No conversation, so basically the big event in the big progress that we experienced came through these two individuals. So we have Karl Marx on one side and the publication of Das Kapital, and we have Darwin on the other with the publication of The Origin of the Species. So Karl Marx was a big fan of Hegel. He really believed in this idea of dialectic progress. And he thought it also applied to economic and social structures. And he said that basically the way progress can happen is only through like a revolution, a big change. And Darwin was not a philosopher, he was a biologist, but simply by presenting the idea of natural selection, of gradual progress over time, that had such a profound impact on so many fields, including philosophy, and the ideas that human progress could also happen in the same way. So we can have progress either through evolution or revolution. So if you think about Swift, Swift is actually kind of a bit of both. On one hand, it's a brand new language, it has new paradigms, we're trying to break away from the past of Objective-C. But at the same time, we're trying to make it easier for Objective-C code to exist in the Swift world. So we have the bridging header, and we have, so this is from a tweet that went around last month by Rob Ricks, saying that the single greatest source of complication to Swift is Objective-C. So we have all these things, we have dynamic, we have at Objective-C, we have the language features functions just to incorporate the past. And also, it doesn't go as far into the future as we would like it to. We don't have, it's not as functional as we would like to be. And the syntax is not as nice. And also, it causes bugs. So I had many crashes where I expected Objective-C code to produce one thing and it produced something else. And that kind of Swift compatibility caused the problems. So this leads us to Nietzsche. Nietzsche is, he's famous for existentialism, but we're not going to talk about existentialism, we're going to talk about his idea of time. So he said that time is circular, and that basically it repeats itself. So your whole life is like a sunglass, it will always be reversed and will ever run out again. Which seems like a big idea. And Schopenhauer kind of took this further, and he had the really pessimist view of this. He said that life should support human interests in some fundamental way, but it cannot. So everything repeats, but it repeats in a flawed way. And the question is Swift basically doomed to repeat the same mistakes we made with Objective-C? Is it either by trying to be compatible with it, or by simply being a new programming language? And I don't know the answer to that, but that's the end of the philosophy of history part. The last thing I wanted to talk about is uncertainty. So the philosophy of uncertainty owes a lot to quantum theory and Heisenberg. but not this Heisenberg. The real Heisenberg coined the uncertainty principle. It's based on the photon double slit experiment. And basically, if you pass a photon through a double slit, the position of the photon is not something that we can determine. There isn't a single position. There is a range of positions. And basically, by trying to determine the position, we're kind of locking it into a specific thing, but that's not actually representing the real state of the thing. So yeah, the exact position and momentum of an atomic particle can only be known within certain limits. And the one way to think about it is to think about reality as a mutable variable that keeps passing through different threads, and we don't have any thread safety. So yeah, it kind of has to do with optionals. So if reality is an optional variable, by the fact that we guard for it, we kind of create a static version of the reality that we pass around, but it doesn't necessarily represent the state of reality at all times. And this, what I like about Swift is that it kind of forces us to accept uncertainty. And we can do functions on things that are not necessarily there. Bertrand Russell is a British philosopher, and he said that uncertainty frees us from the tyranny of dogma. By accepting uncertainty, we are opening ourselves up to all possibilities. And that gives us a lot of freedom. And yeah, it allows us to stress a lot less about our code and our lives. And that's it for the history of uncertainty. Now, let's get to the conclusion. So what was this all about? Basically, this was I was trying to think differently about this code that I deal with every single day. And by doing that, I think we can learn something new. I think it can make us better developers, and maybe it can even make us better people. And it's something that I'd like to encourage you to do, maybe not with philosophy, maybe with something else that you care about. And yeah, I promised you a cat gift. So there you go. And thank you very much.
Okay, so questions?
I'm quite interested in the theme. I believe nowadays I know a lot of people that are interested in philosophy, and it's good that people try to bring some knowledge to our community. And I would like to do kind of an abstract question.
Okay, sure.
So you said all philosophers are connected and they feed each other ideas and make a vocabulary along the way.
Mm-hmm.
Kind of that. So, who are the Swift philosophers? And what vocabulary did they introduce? And the main ideas they defend?
Yeah. I guess...
Well, don't count Roy as one of them, because...
I guess Chris Lattner is the Socrates of Swift. But yeah, I think like the fact that we kind of engage in this conversation, and the fact that we have the open source community, is when there's a new open source framework, that's kind of like a new philosophical paradigm in some way. And the fact that we have this GitHub issues and pull requests means that everyone can be part of it, and we are less likely to create these sort of towering figures and more likely to create a better community of people who can be a part of this, I guess. We can all be philosophers.
Okay. But I understand that, but I believe that we have in our community some people that push forward some ideas. Like we have Justin that pushes Rack forward, and BVM, and people like that. And it is interesting to think in terms of ideas, what they bring to the table. And sometimes they are inspired by other things, like RX, Swift, inspired by RX in general. So I would like to think in people that kind of lead the way in terms of our philosophical ideas.
Yeah, that's interesting.
Hi,
Hi.
it was a great talk. Regarding that forms part where you talked about inheritance and all that stuff, so you were basically saying that inheritance is like a way of the past, thinking about forms, and protocol, component-based architectures were the future. So how do you think about, for example, UIKit? Do you think that UIKit is still stuck in the past regarding that?
I don't know. I think there are two different ways of thinking about it. I know Apple is very keen on pushing this idea of sort of protocol-oriented programming, and maybe that is the future. But yeah, I don't think anything is less valid. Yeah, and it works for UIKit.
Okay.
Yeah.
So, for example, for me, the UI button class, it assumes a lot of stuff about the content of the button. When for me, a button is just a thing that when you click, it executes something.
Yeah.
So I was just thinking if
I would like to see a protocol like
protocol-based
of UIKit.
Yeah,
would be really
me
interesting.
too. Okay, thank you.
Fantastic. Awesome.
Thanks.
And actually, I was just thinking that I really would love to see a protocol that just adds botonity to any view, because a lot of things can be tapped. Sure, of course. Yeah. So what I was thinking was, do you think that it's possible for Swift to not make the same mistakes as Objective-C, provided it's different people that are working on it?
Yeah. Well, I think, so I believe that actually this kind of backwards compatibility is hurting, is what's bringing these like problems into Swift.
So you're a Marxist.
I'm a Marxist. But yeah, I think, so the problem of having, like if you had a brand new programming language with no backwards compatibility, I think we wouldn't see the kind of adoption that we're seeing with Swift, where it's the fastest growing language on GitHub and whatever. So there is definitely a trade-off, but I think by going for this quick adoption, we're kind of sacrificing the beauty and the perfection of what we're creating.
So right now we're just trying to really run through repeating the mistakes so we can get to the version that it's already better.
And that will be as well, maybe.
Okay.
Yeah.
Okay. Yeah. Thank you.
All right.